sediment in streams ends up being really important. Now, sediment in streams can interact in three ways. The sediment can be eroded, it can be transported, and it can be deposited. What the stream is doing in each one of these cases has to do with how fast the water goes. So this goes back to that discussion we had earlier about velocity of the river. The faster the water goes, the more sediment it can transport. Water is going to transport just as much as it can. That means if all of a sudden it speeds up and it can hold more, it'll start eroding to pick up more. Or if it's carrying sediment and it slows down, it's going to start depositing to match that balance. So in all these cases, it's really about the velocity. We've looked at examples of how streams erode, whether at the bed or the bank, based on their how close or far they are from base level. So now we're going to look at how sediment is transported and deposited. So transportation by streams comes in three varieties. You have the gravel, the sand, along the bottom. You have silted clay that's in the current, and you have ions and compounds that are dissolved in the water. So those are your three types of transportation. Let's look at these a little bit closer. We have what's called dissolved load. Dissolved load is either single elements or compounds that are dissolved in water. We've talked about rocks and minerals before that dissolve easily in water. For instance, halite, salt, dissolves pretty easily, but so does limestone, and limestone creates calcium carbonate. This is a picture from Havasupai Reservation inside the Grand Canyon. These are really famous waterfalls and pools. Notice this pool is a really pretty blue-green color. It's actually the color of the water. It's blue-green because it's carrying so much dissolved calcium carbonate from the limestones throughout the Grand Canyon. This is found on the Havasupai Reservation, and the Havasupai name actually translates to people of the blue-green water. So they're actually named for this. That's as opposed to the Wallapai that live up out of the canyon, and those are the people of the pine trees. They live up where there's lots of pines. But in this case, the blue is thanks to all that limestone, and what that does is it deposits lots of travertine. So it overhangs a lot of this you see on the walls are travertine deposits. It also creates a little travertine dam, and that's why there are these beautiful pools. But dissolved load is super easy to recognize thanks to this blue color. Now, suspended load, if you suspend something, it hangs, right? So suspended load in a stream is either silt or clays that are suspended in the water column, and they don't actually touch the bottom. So this is an example from a water flume in one of the labs at ASU. Dr. Schmeckley runs this lab. I actually took a rivers class from him. But you can see all these little pieces up here, they just go floating by. They're not falling, they're not rising, they're just floating in there. That makes suspended load. A suspended load, since it's so much silt and so much clay, the water tends to look really muddy. So when you see a really muddy river, that's an indication that you have suspended load. Finally, we're going to look at these big pieces. So you have sand and gravel that hops, slides, and rolls along the bed. Wait a minute, here we go. So you can see the sand looks kind of cloudy. Sand saltates. So it actually hops. It goes up in the water column and then falls back down. It kind of hops its way down. We call this saltate. We'll talk about that again when we talk about deserts and sand dunes, because it does the exact same thing in wind. You have these pebble-sized pieces that are rolling along and bouncing along. And you have a little bit bigger pieces that they don't quite roll, but they slide along the bottom of the bed. So that's what's called bedload, as these are all in contact with the bed. Now, obviously, the bedload is going to be the first thing that's deposited when your river slows down. In order to deposit that mud of suspended load, it has to be moving very, very slow. And since the rivers can carry, they also deposit. Now, sediment that's been deposited by a stream is called alluvium. It's a beautiful example of a point bar on a river, one big bend in the river. So the sand and gravel is deposited here in the middle, so that's an example of alluvium. Here's a couple of really famous, really common stream depositional features. For one, a delta. When a river flows into a standing body of water, like a lake or like an ocean, that water slows way down because it's literally at base level and it doesn't like to keep flowing. So in that case, it's going to deposit a bunch of stuff. As you can see here, eventually it deposits so much that the river can't keep moving. And rule number one was a river needs to keep moving. Rule number two is it needs to reach base level, right? So in order to keep moving, the river cuts a new angle, so it's a little bit steeper, and it moves and deposits, and then it moves again, and then it moves again, and so you have this big sweeping area of channels that are distributing the water back out. This creates a delta, and this is because the water slows down. So in the U.S., we usually talk about the Mississippi River Delta. This is called a bird foot delta. Thanks to its shape, it looks kind of like a chicken foot. And this delta itself has moved over time. Rivers are really mobile features. So it used to be depositing way out here, where this river is. Then it moved, and where New Orleans is right now was just off the coast. Then it moved back over here, then it moved back over there, then it moved back over here, then it moved back over there. And right now, it's kind of its furthest extent out, which means that eventually it's going to want to move again. And the U.S. Army Corps of Engineers works really hard to keep that river where it is for the people of New Orleans and for the shipping in the area. One of the famous deltas in the world is the Nile River Delta. This is where the Nile ends up emptying in the Mediterranean Sea in Egypt. Now, this is a really fertile area because of that. At least it used to be. There's a big dam on it now, so not quite as green. What do you notice about the shape of this here delta? Looks kind of like a triangle, right? Oddly enough, not oddly, it's actually totally uncoincidental. That is the Greek letter delta. So the Greek letter delta and the shape actually comes from the Egyptian Nile Delta. There's a little etymology for you today. Now, not every river actually empties into standing water. When a stream leaves a mountain front or off of a cliff, it enters a wide flat plain, the water slows down and separates into many smaller streams known as tributaries, not as distributaries. Sorry. So tributary is all contributing to a stream, and at the mouth of the stream you get distributary channels. And that's what all these little channels are, emptying out. This forms what's known as an alluvial fan. This right here is one of the more famous locations for these in Death Valley. Death Valley, you might be surprised, the first time I went, I expected it to be like really big and flat and deserty. When actually, on one side of Death Valley, you've got a bunch of mountains. Then you have the valley down here, and then you have a whole bunch of other mountains on the other side. The highest point in those is Telescope Peak, and during the winter, Telescope Peak actually has snow on it, which is bizarre, right? But what's going on here is these mountains on either side are just horsed. And Death Valley sits on a down-drop robin, and it's actually still dropping down. So what happens is, as rivers are coming off of those mountains, they're moving really fast, coming down those cliffs, but then all of a sudden they hit this super flat valley in the middle, and everything just gets deposited out. That's why you get this big, beautiful splay, alluvial fan shape. These are some of my favorites.